Remember the thrill of starships jumping to hyperspace in science fiction? The exhilarating moment when the stars stretch into lines and the ship catapults into the unknown? The idea of traveling faster than light, a concept long confined to the realm of imagination, has captivated scientists and dreamers alike. For decades, this notion has fueled countless stories, inspiring generations to look up at the night sky and wonder what lies beyond our reach. What if we could traverse the vast cosmic ocean, reaching distant stars and galaxies within a human lifetime? Imagine the possibilities, new worlds to explore, new civilizations to meet, and the expansion of human presence across the universe. This dream, while seemingly impossible, finds a glimmer of hope in the realm of theoretical physics, particularly in the concept of warp drive. The idea that we could bend the very fabric of space and time to our will is both thrilling and daunting. Warp drive, a term popularized by science fiction, represents the holy grail of space exploration. It's a beacon of hope for those who yearn to break free from the confines of our solar system and venture into the great unknown. It's a technology that would allow us to overcome the limitations imposed by the speed of light, the seemingly insurmountable barrier to interstellar travel. By warping space, we could theoretically travel vast distances in a fraction of the time it would normally take. Our current understanding of physics suggests that nothing can travel faster than light in the conventional sense. This speed limit, set by the universe itself, has long been a roadblock for our dreams of interstellar travel. But what if we could manipulate the fabric of space-time itself, creating shortcuts and wrinkles that would allow us to cheat the cosmic speed limit? This idea, while radical, opens up a world of possibilities. This concept isn't just the stuff of science fiction, it has roots in theoretical physics, specifically in Einstein's theory of general relativity. Einstein's groundbreaking work has provided a framework for understanding how we might one day achieve faster-than-light travel. This theory, which describes gravity as the curvature of space-time, opened up a Pandora's box of possibilities, including the potential for warping space-time to achieve faster-than-light travel. By bending space around a ship, we could theoretically move from one point to another almost instantaneously. While still highly speculative, the idea of warp drive has sparked serious scientific inquiry, pushing the boundaries of our understanding of the universe and our place within it. Researchers around the world are exploring the mathematical and physical principles that could one day make warp drive a reality. The allure of warp drive lies not just in its potential for interstellar travel, but also in its implications for our understanding of the universe. If we could manipulate space-time to such a degree, it would open up a whole new realm of possibilities, allowing us to explore the cosmos in ways we can only dream of today. If we could manipulate space-time to such a degree, it would open up a whole new realm of possibilities, allowing us to explore the cosmos in ways we can only dream of today. The potential for discovery is limitless, from new planets and stars to entirely new forms of life. While the realization of warp drive may still be far off, the very act of exploring this concept pushes the boundaries of human ingenuity and inspires us to reach for the stars. It challenges us to think beyond our current limitations and to imagine a future where the stars are within our grasp. The journey to warp speed is as much about the quest for knowledge as it is about the destination. One of the most intriguing concepts to emerge from the study of warp drive is the Alcubierre Drive, a theoretical model proposed by physicist Miguel Alcubierre in 1994. This idea has captivated the imaginations of scientists and science fiction enthusiasts alike. Alcubierre's idea was to create a warp bubble around a spacecraft, a region of spacetime that contracts in front of the ship and expands behind it. This would effectively allow the spacecraft to travel vast distances in a fraction of the time it would normally take. Imagine a surfer riding a wave. The surfer doesn't move through the water faster than the wave itself, but rather is carried along by the wave's motion. This analogy helps us understand how the Alcubierre Drive would work. Similarly, the Alcubierre Drive doesn't propel the spacecraft through spacetime faster than light, but rather distorts spacetime itself, creating a wave that carries the spacecraft along. This wave, or warp bubble, would allow the ship to effectively move faster than light without breaking the cosmic speed limit. This concept, while mind-boggling, doesn't actually violate Einstein's theory of relativity. Einstein's theory states that nothing can travel faster than light through spacetime, but it doesn't say anything about the speed at which spacetime itself can expand or contract. This distinction is crucial in understanding how the Alcubierre Drive could theoretically work. The Alcubierre Drive exploits this loophole, creating a localized distortion of spacetime that allows for effective faster-than-light travel without violating any fundamental physical laws. This means that while the spacecraft itself isn't breaking the speed of light, the space around it is being manipulated in such a way that it can achieve incredible speeds. To visualize this, imagine a flat sheet representing spacetime. Place a small ball on the sheet to represent your spacecraft. Now imagine pushing down on the sheet in front of the ball while pulling it up behind the ball. This creates a dip in the sheet that carries the ball along with it. This is a simplified way to understand how the contraction and expansion of spacetime would move the spacecraft. In the Alcubierre Drive, the contraction of spacetime in front of the ship creates this dip, while the expansion behind the ship pushes it forward. This dual action of contracting and expanding spacetime is what makes the Alcubierre Drive so fascinating. The beauty of the Alcubierre Drive lies in its theoretical plausibility. It challenges our understanding of physics and pushes the boundaries of what we believe is possible. While it requires exotic forms of matter with negative energy density, a concept we'll explore later, this exotic matter is essential for creating the warp bubble. The underlying principles are consistent with our current understanding of general relativity. This means that, in theory, the Alcubierre Drive could work without contradicting the laws of physics as we know them. This makes the Alcubierre Drive more than just a flight of fancy. It's a tantalizing possibility, a glimmer of hope that faster-than-light travel might one day be within our reach. The dream of exploring distant stars and galaxies could become a reality, thanks to the innovative thinking behind the Alcubierre Drive. While the Alcubierre Drive and other warp drive concepts offer a glimmer of hope for faster-than-light travel, they also present a formidable challenge: the sheer amount of energy required. The idea of bending spacetime to create a warp bubble is tantalizing, but the practicalities are daunting. Creating a warp bubble, according to Alcubierre's calculations, would require an astronomical amount of energy, equivalent to the mass energy of Jupiter, or even larger celestial objects. This is not just a small hurdle, it's a cosmic speed bump that forces us to rethink our approach to interstellar travel. To put this into perspective, consider the total energy output of the Sun. Our Sun, a massive ball of burning plasma, releases an unimaginable amount of energy every second, enough to power our entire planet many times over. Our Sun, a massive ball of burning plasma, releases an unimaginable amount of energy every second. The energy it emits is so vast that it sustains life on Earth and drives our climate and weather systems. Yet even harnessing the entire energy output of the Sun wouldn't come close to meeting the energy requirements for warp drive. The energy needed is orders of magnitude greater than anything we can currently produce or even imagine producing with our existing technology. We're talking about energy scales that dwarf anything we can currently comprehend or generate. The gap between our current capabilities and the energy needed for warp drive is staggering. This energy barrier represents a significant hurdle in the quest for warp drive. It's a challenge that requires us to think beyond conventional energy sources and explore new frontiers in physics. It's not simply a matter of building bigger power plants or finding more efficient energy sources. It's about tapping into energy sources that are currently beyond our technological reach. We need to innovate and discover new ways to generate and harness energy on an unprecedented scale. To overcome this barrier, we need to explore the fringes of physics, delving into the realms of exotic matter, antimatter, and even the mysterious force known as dark energy. These are not just theoretical concepts. They represent the next frontier in our understanding of the universe. These potential energy sources, while still largely theoretical, offer a glimmer of hope. They could provide the breakthrough we need to make warp drive a reality, but they also require us to push the boundaries of our scientific knowledge. They represent the cutting edge of our understanding of the universe, and exploring their properties could hold the key to unlocking the secrets of warp drive. This is a journey that will take us to the very limits of what we know and beyond. The challenge lies not only in harnessing these exotic forms of energy, but also in doing so in a controlled and sustainable manner. We must ensure that our pursuit of warp drive does not come at the cost of our planet or our future. This is the ultimate test of our ingenuity and our commitment to exploring the cosmos responsibly. One of the most intriguing concepts in theoretical physics is exotic matter, a hypothetical form of matter with negative mass energy density. Unlike ordinary matter, which has positive mass-energy density and creates gravity, exotic matter is theorized to have negative mass-energy density, meaning it would repel gravity rather than attract it. This bizarre property of exotic matter, while seemingly counterintuitive, has profound implications for warp drive. Remember the Alcubierre Drive and its requirement for contracting spacetime in front of the spacecraft? That contraction, according to Alcubierre's calculations, would require matter with negative mass-energy density, precisely the kind of property exhibited by exotic matter. In essence, exotic matter could act as the fuel for warp drive, providing the negative energy density needed to warp spacetime and create the warp bubble. By strategically placing exotic matter around a spacecraft, we could theoretically manipulate the curvature of spacetime and achieve faster-than-light travel. However, there's a significant catch. Exotic matter, while theoretically possible, has never been observed in nature. Its existence remains purely hypothetical, confined to the realm of mathematical equations and thought experiments. Whether exotic matter exists in our universe, and if so, whether we can ever hope to harness its bizarre properties for our technological purposes remains an open question.